You know, starships jumping to light speed, crossing entire galaxies in the blink of an eye. It's the dream, right? The very heart of science fiction. But what if I told you it wasn't just fiction? In this explainer, we're going to pull back the curtain on the very real, very serious science behind warp drives. And honestly, you might be shocked to find out just how close we're getting.
Okay, so before we can jump to the solution, we have to get our heads around the problem. And the problem is space. The just staggering, mind-boggling emptiness of it all. Our solar system? It's a tiny, tiny little island in a vast cosmic ocean. And just getting to the next island over, well, that's the biggest travel challenge humanity has ever faced.
Take a look at this number, 75,000 years. That is how long it would take Voyager 1, the fastest thing we have ever sent out into the void, to reach our nearest stellar neighbor, Proxima Centauri. Let that sink in. That's not just a long time, that's longer than all of recorded human history. So yeah, even when we look ahead at fancy future tech, like advanced nuclear electric propulsion, we're still looking at journeys that take thousands of years. The conclusion here is pretty stark. If we ever want to reach the stars in a human lifetime, we don't just need a faster ship, we need a completely new way of thinking about travel itself. And this is where things get really weird, in the best possible way. See, the universe has a speed limit, the speed of light, and you can't break it. But what if you didn't have to? What if instead of trying to fly faster through space, you could just move space itself? Now that is a loophole that could change absolutely everything.
I mean, this image just says it all, doesn't it? It's the dream. And it's a concept that was actually formalized way back in 1994 by a physicist named Miguel Alcubierre. He came up with a theoretical warp drive that doesn't break Einstein's laws at all. Instead, it kind of finds a clever way around them.
The truly elegant thing about the Alcubierre drive is that the ship inside this warp bubble, it isn't actually moving, not at all. It's just sitting there, at rest. Imagine being in a room that's perfectly still, but the entire universe is rearranging itself around you. That's the core idea. The drive isn't pushing the ship, it's pushing the chunk of space-time that the ship happens to be in.
The best way to think about it is like a surfer on a wave. A surfer isn't swimming through the ocean at 30 miles an hour, right? No, they're riding a wave that's moving the water itself. A warp drive would do the same thing, but with space-time. It would create a wave, squeezing the space in front of the ship, pulling your destination closer, and stretching out the space behind it, pushing your starting point further away.
Now, for decades, this beautiful, elegant theory had one massive show-stopping problem. A catch so big, it basically kept the whole idea of a warp drive locked firmly in the realm of science fiction. Okay, so bending space-time like this, it's got to take a phenomenal amount of power, right? The question that stumped everyone was, what kind of fuel could possibly do something so extreme? And wow, this quote from a 97 paper just lays it all out. The energy required was, just a bit more than the entire visible universe. But that wasn't even the real killer. The real killer is that last word, negative. It wasn't just about needing a lot of energy. It was about needing a kind of energy that, as far as we know, can't and doesn't exist.
And that's the roadblock. This is the big one. We're talking about so-called exotic matter with properties that just fly in the face of known physics, something that would have anti-gravity. It's stuff we've never seen, have no idea how to make, and for a very long time, this was pretty much the end of the conversation.
But, science is all about poking at your assumptions. And not too long ago, a team of physicists did exactly that. They went all the way back to the original warp drive math and asked a really simple question. What if we've been looking at this the wrong way? And what they found, well, it has completely reignited this entire field. This is a massive shift in thinking, a total pivot. Instead of trying to find some magical, non-existent energy source, this new approach says, hey, what if we treat space-time itself like a kind of fluid? And when they did that, they started finding solutions to Einstein's equations that could, in theory, be powered by normal, everyday positive energy.
A paper that came out in 2021 really changed the game. By modeling space-time as this special kind of fluid, physicists figured out it might actually be possible to create a warp bubble using only positive energy. The math lines up. It suggests a warp bubble could act kind of like a shockwave, just surfing through the fabric of the universe. I mean, this was a huge breakthrough. The main takeaway? Negative energy might not be a deal breaker after all.
So this new theory is incredibly exciting. But you want to know what's even more thrilling? This stuff isn't just on paper anymore. Right now, as we speak, scientists are running actual, physical experiments to take the very first baby steps toward making this real.
Seriously. Down at NASA's Eagle Works laboratory, a team led by Dr. Harold Sonny White is taking these wild ideas and turning them into things they can actually test. Now, to be clear, they are not building a starship in a secret hangar somewhere. Their goal is way more fundamental: to prove that we can, in fact, bend space-time on command, even a tiny bit.
And the benefits here aren't just for reaching other stars 100 years from now. Even a tiny little warp effect, something way, way slower than the speed of light, could completely change travel inside our own solar system. Just look at this chart. A pretty modest warp field could take a 70-day trip and cut it down to 40, basically by making the spacecraft feel lighter to spacetime. So, how in the world do you actually measure a warp bubble? Well, you use this thing, the Warp Field Interferometer. It is a hypersensitive laser device. The idea is to create a really powerful electromagnetic field in a tiny space, and then use this incredibly precise laser to see if it can detect a microscopic ripple, a tiny little disturbance in the fabric of space-time itself.
We're talking about measuring a distortion that is almost unimaginably small. But, and this is the big but, if they can do it, if they can prove that we can warp spacetime, even by the tiniest fraction, Dr. White says it would be a Chicago pile moment. And that's a reference to the very first self-sustaining nuclear reaction, a tiny experiment that proved a new kind of physics was possible and, well, ultimately changed the entire world.
You know, in his scientific paper, Dr. White actually includes this quote from Peter Pan, and I think that's just perfect. It's this powerful reminder that, at its heart, this isn't just about equations and engineering. It's about that deep, fundamental human need to explore, to see what's over the next hill, and to, literally, reach for the stars.
So, where does this all leave us? Is this just a sci-fi fantasy, or is it humanity's next giant leap? The road from these tiny lab experiments to a full-blown starship is going to be incredibly long, but for the first time in human history, we can actually see the path. The science is telling us that a warp drive isn't impossible, just really, really hard. And you know what? That changes everything. The question isn't if we'll reach the stars anymore, it's when.